Welcome to the deep dive. Okay, so think about the last time you bought groceries online. You almost certainly started with a search, right?
Absolutely. Yeah. Typing in the basics, probably.
Yeah, like milk or apples. But, what if you're looking for something less obvious? Or maybe you're just browsing. Online grocery search, it turns out, is deceptively complex.
It really is.
So today we're doing a deep dive into how Instacart, the leader in online grocery here in North America, is, well, radically transforming its search and discovery using advanced AI.
Mm.
We're talking large language models, LLMs.
Mm.
Our mission today is really to unpack how they tackled some pretty significant challenges to make online grocery shopping smarter, more intuitive, and, let's be honest, a lot less frustrating sometimes.
Exactly. And we're going to explore this, right from the ground up. We'll start with why search is just so fundamental for grocery e-commerce. Look at the inherent hurdles, the things that trip up conventional search engines in this specific area. And then the really crucial part, precisely how LLMs were deployed to get over those hurdles. And we'll also touch on some of the, well, surprising and maybe counterintuitive lessons Instacart learned along the way. It's a fascinating journey.
Okay, let's really dig into this then. Why is grocery search uniquely difficult? I mean, compared to finding, say, a specific book online, you often come to Instacart with a pretty long shopping list, right? We're talking tens of items, maybe.
Yeah, tens of items at once. And it's an interesting mix, too. Most of it is restocking purchases, the things you buy week in, week out, milk, bread, eggs.
The usual suspects.
Right. But then there's also a significant chunk that's new items, things you're exploring, trying out.
Ah, okay. So search has this dual role then. It needs to efficiently find the stuff you already know you want.
Here, get you your regular brand of yogurt fast.
But it also has to enable that discovery of new products.
Exactly. And that discovery piece, it's not just good for you, the customer. It's also great for advertisers wanting to showcase new things. And naturally, it encourages larger basket sizes for Instacart itself. More discovery, more buying.
Makes sense.
And that dual role creates, well, two main classes of really challenging queries for traditional search engines. First up, you've got those overly broad queries, like just typing in snacks.
Right. What kind of snacks?
Yeah.
Salty, sweet, healthy?
Precisely. The issue is tons of products map to that query, a huge number. And without specific historical engagement data, data showing users clicking on these specific snacks after searching snacks, it's incredibly difficult for conventional models to rank them effectively.
Is that the cold start problem I hear about?
That's exactly it. When you have new items or these broad categories with no real interaction history, the system just doesn't know how to surface them properly. Then you have the other extreme, very specific queries.
Like what else?
Think unsweetened plant-based yogurt, very specific.
Okay, yeah.
These searches just don't happen that frequently, which means, again, there isn't enough engagement data available to train the models reliably. So while traditional methods might get better at recall, meaning they can show some relevant results, maybe any plant-based yogurt precision is still a challenge.
So you might get results, but not exactly the unsweetened kind you wanted.
Exactly. They might be related, but not quite right.
That makes a lot of sense. Okay, so beyond just finding that one specific item, what about discovery? You mentioned the pasta aisle analogy earlier, like in a physical store, you see the pasta, but also new brands, different sauces, maybe related ingredients.
Right, that's serendipitous discovery.
Customers want that online too. Instacart actually heard feedback like, I can find the product that I want via search, but when I'm trying to find any other related products, it's a bit of a dead end.
Yeah, you find your pasta, but then you have to do a new search for sauce, a new search for Parmesan.
Exactly. It forces multiple searches.
Yeah.
And traditional methods just, well, they struggle to create that rich, exploratory experience. Why?
Primarily due to that same persistent lack of engagement data for new or related items. The system just didn't know what to suggest.
Okay, so the stage is set. Traditional search has its limits here.
Which brings us squarely to query understanding, or QU. QU is really the most upstream part of the search stack. It's the very first step in figuring out what a user truly means when they type something in.
Upstream meaning it happens first, before anything else.
Exactly. And because it's first, very accurate outputs are needed. Any mistakes or vagueness here just cascades downstream.
Messes up everything that follows.
Pretty much. It directly impacts the quality of retrieval, what products get pulled, and ranking how they're ordered. Instacart's QU module, it's not just one thing. It actually involves multiple sophisticated models working together. They handle stuff like query normalization, tagging different parts of the query, classification. It's complex.
All right, so let's dive into their first big application of LLMs within this QU system, the query to category classifier. What's the job here?
The task sounds simple. Map a query, like watermelon, to relevant categories within Instacart's huge internal product organization system, their taxonomy.
How huge are we talking?
It boasts about 10,000 labels in total, though in practice about 6,000 are commonly used.
Still 6,000 categories. Wow, okay.
So watermelon might need to map to fruits, maybe produce, perhaps organic foods if that's relevant. And crucially, a query can belong to multiple categories, right? So it's a multi-label classification problem.
Gotcha. So what were they using before LLMs? You mentioned traditional models.
Yeah, they try various things, even sophisticated ones like fast text or BERT-based models. BERT's pretty powerful for general language stuff.
Right, you hear a lot about BERT.
But they hit limitations. They worked okay for the head and torso queries.
The common searches.
Exactly, the popular stuff. But they had really low coverage for our tail queries.
Those super specific ones again?
Yep, because same story for those less common searches, there just wasn't enough historical engagement data to train the models effectively.
And BERT, did that help?
It offered some improvement, yeah, but it also significantly increased latency, slowed things down without really delivering the big wins they were hoping for. Sort of a trade-off that wasn't worth it.
Okay, so the traditional stuff wasn't cutting it for the long tail. Enter the LLM.
Exactly. So they thought, okay, let's try an LLM.
Mm.
The initial idea was pretty straightforward. Just feed the query, like watermelon, and a list of possible categories, the taxonomy, into the LLM and ask it to pick the best ones.
Makes sense. How did that go?
Well, internally, when the engineering team looked at the output, it made a lot of sense. It was logical. The connections seemed right.
But there's always a but.
But when they ran it in an actual online A/B test, comparing it to the old system, the results weren't as great. Users weren't clicking or buying more.
Huh. Why the disconnect? If it looked logical.
The protein example they shared really nails it. For Instacart users, when they type protein, they're usually looking for protein shakes or protein bars. That's the user intent in that context.
Right. Stuff you buy at a grocery store labeled protein.
Exactly. But the LLM, drawing on its vast general world knowledge, might think, protein, chicken, tofu, lentils, protein foods.
Which isn't what the Instacart shopper typically means by that single word query.
Precisely. It highlights this crucial point.
Mm-hmm.
The LLM's general knowledge, its common sense, often doesn't truly understand Instacart user behavior or specific shopping intent.
That's a really powerful insight. So the general knowledge was actually a problem here. What was the breakthrough then? The aha moment to make the LLMs actually work for this grocery context?
It came when they, as they put it, switched the problem around. Yeah. Instead of just feeding the query and the giant list of categories to the LLM,
they added something else.
Yes. They also fed it the most commonly converting categories or the top K converting categories for each query as additional context to the LLM.
Wait, so they told the LLM for this query, users usually end up buying things from these categories.
Exactly. They gave it Instacart-specific user behavior patterns. They essentially started teaching the LLM the language of Instacart user intent, grounding its general knowledge in real-world shopping data.
That's fascinating. So you're guiding the LLM with actual user actions. Did it work?
It made a huge difference. Take their Wayner soda example, maybe a typo or a regional brand. Their previous traditional model identified it vaguely as fruit-flavored soda. Not wrong, technically, but not very helpful.
Okay.
The LLM, with that added context of top converting categories for similar queries, did much better. It correctly identified it as ginger ale.
Ah, much more specific.
Way more specific.
Yeah.
And that accuracy then greatly improved the downstream results the actual product shown.
And the numbers, did they see real improvement?
Oh, yeah. Especially for those tricky tail queries. They saw precision improve by a remarkable 18 percentage points.
18? That's substantial.
And recall finding any relevant result improved by a massive 70 percentage points. 70.
Wow. So way fewer searches ending with bad or no results for those specific items.
Exactly. Huge wins. And interestingly, the prompt they used to give the LLM this context was apparently very simple. Nothing fancy, just passing in those top converted categories.
Incredible. Okay, so they've improved understanding the queries category. What next? Building on that, they tackled another key area, the query rewrites model.
Right. This is super important for e-commerce generally, but especially at Instacart. Why? Because not all retailers carry the same items, right? Catalog sizes vary wildly.
Yeah, my corner store doesn't have everything the big supermarket does.
Exactly. So a query that returns great results at one store might give you 0 results at another. That's a bad experience.
So a rewrite helps bridge that gap.
Precisely. A simple example is rewriting 1% milk to just milk. That way, even if the store doesn't specifically label 1% milk but has other milk, you still see some relevant results. It ensures you don't hit a dead end.
Makes sense. Prevent empty result pages.
And again, their previous approach, which relied on engagement data, was decent for common queries.
Let me guess.
But it suffered from a lack of engagement data on tail queries. Same problem.
Okay, so LLMs for rewrites too.
Yep. By leveraging an LLM, they found they could generate very precise rewrites that offered a lot more flexibility. They could do different types of rewrites, like a substitute. If avocado oil isn't available, rewrite to olive oil.
Okay, a direct alternative.
Or a broader rewrite. Avocado oil could become healthy cooking oil to show more options.
Widen the net a bit.
Or even a synonymous rewrite, like maybe avocado oil to avocado extract, if that's relevant in their catalog somehow.
Interesting. Different strategies for different situations. And did this help online?
Big time. It led to a large drop in the number of queries without any results.
So fewer people seeing that dreaded no results found page.
Exactly. Which meant they could now actually show results to users where they previously saw empty results. And that was obviously great for the business and way better for user satisfaction.
Okay, so understanding queries better, rewriting them smartly. That covers finding the specific thing. But what about that discovery piece? You know, that feeling when you search for one thing, you find it, but then you're kind of left hanging.
Yeah, the okay, now what moment.
Like, found my pasta, now, sauce, garlic bread, maybe some cheese.
Instacart wanted to solve that dead-end problem right on the search results page.
Their goal was explicitly to show more discovery-oriented content, moving beyond just the exact match for the query.
How did LLMs help there?
Well, they found LLMs could help generate relevant discovery ideas without needing a lot of feature engineering or manual work, which is how you might have tried it before. They used it in a couple of ways. For queries that had no exact results, maybe you search for swordfish and the store is out.
Yeah, instead of just an empty page.
Instead of an empty page, the LLM could generate substitute results. Things like other seafood alternatives or maybe meaty fish like tilapia. Suggestions to keep you going.
That's helpful. And for queries with lots of results, right? The opposite scenario. Maybe you search for sushi, you get lots of sushi kits or pre-made sushi. But then at the bottom of the page, the LLM could show complementary items. Things like Asian cooking ingredients, maybe soy sauce, wasabi, or even Japanese drinks.
Anticipating the rest of your meal or related needs.
Exactly. And they found both of these approaches, substitutes for no results, complements for lots of results, led to improvement in engagement as well as improvement in revenue. People clicked and they bought.
That's really powerful. But generating this kind of content sounds tricky to get right. What were the key requirements?
Two main things stood out. First, the content needed to be incremental, meaning it shouldn't just duplicate stuff already shown in the main search results. It has to add new value.
Okay, no repeats. Makes sense.
And second, and this is crucial, it had to be aligned with Instacart's domain knowledge. It needed to understand the grocery context.
Can you give an example?
The word dishes is a great one. If a user just searches dishes in a grocery context, they probably mean cookware, right? Plates, bowls, maybe dish soap.
Yeah, probably not dinner recipes.
But if the user searches Thanksgiving dishes, the context completely flips. Now, it should understand dishes to mean food items related to a Thanksgiving meal, turkey, stuffing, cranberry sauce, etc.
Wow. Okay. The context changes the meaning entirely. The LLM needs to get that nuance.
Absolutely. So their first attempt at this discovery generation was, as they put it, a very basic generation approach. They basically just prompted the LLM to act as an AI assistant and generate lists of complementary items and substitute items for a given query.
And how did that look initially?
Well, the results looked pretty good internally to product managers. Seemed reasonable.
I sense another but coming.
But when they launched it, users weren't engaging it as much as we would have liked. People weren't clicking on these AI-generated suggestions.
Déjà vu. Why not this time?
It came back to that same core problem we talk about with query understanding. The LLM's answers, while often common sense based on its general knowledge, weren't reflecting what Instacart users actually wanted or how they behaved in that specific shopping context.
The protein problem again?
Exactly, the protein problem.
Huh.
The LLM might suggest chicken or tofu as substitutes or complements, but Instacart users were actually looking for protein bars and shakes in that context. The general knowledge clashed with the specific user intent.
So, if I'm getting this right, simply asking a powerful general LLM to be helpful wasn't enough. Its general world knowledge was actually a hindrance without that specific Instacart context.
You nailed it. That seems to be the recurring theme.
So, what was the solution for making discovery work better then? How did they fix it?
Predictably, perhaps. The solution once again was to augment the prompt with Instacart domain knowledge. Give the LLM more context specific to how Instacart users behave.
Okay, what kind of context did they add at this time for discovery?
They added several specific pieces of metadata into the prompt itself. First, the top converting categories for that query, similar to what they did for QU.
Okay, what users actually buy?
Second, any annotations they already had from their query understanding model, like did the QU model detect a specific brand name or a dietary attribute like gluten-free in the original query? Pass that info along.
So the LLM knows more about the user's constraints or preferences.
Exactly. And third, this one's really interesting. Subsequent queries that users did once they issued this particular query.
You mean, what did people search for next?
Yes. If someone searched for pasta, and then a significant number of users immediately searched for marinara sauce, that sequence, that behavioral pattern, became valuable context fed into the LLM prompt for the original pasta query.
That's brilliant. It's like teaching the LLM common shopping journeys or missions specific to Instacart.
It really is. It's grounding the LLM's generation in actual user behavior paths.
And the result. Did this augmented prompt work better?
They said it led to far more better results, much more relevant and useful suggestions. And crucially, they saw a huge improvement in both engagement as well as revenue from these context-aware discovery modules.
So again, the key was blending the LLM's power with deep, specific user context.
That seems to be the magic formula they found. Now, switching gears slightly, let's talk about the back end. The tech challenge of actually scoring and serving these LLM output efficiently.
Right, because LLMs can be slow and expensive, can't they?
They certainly can be. And Instacart has this very particular query pattern we mentioned. A fat head and torso set, a relatively small number of queries searched extremely frequently, and then this massive long tail of queries that are each searched very rarely.
So you can't just call a big LLM in real time for every single search query.
Exactly. The latency would be too high, the cost would be astronomical. It's just impractical at their scale.
So what was their technical solution?
Pretty clever, actually. They used caching heavily. They pre-computed the outputs for all of the head and torso queries offline in a batch mode.
Meaning, for all the common searches, they figured out the best categories, rewrites, and discovery items ahead of time.
Correct. They ran the LLMs offline, generated the results, and stored them in a cache. Then, online, when one of those common queries comes in, the system just serves the pre-computed roles straight off of the cache with very low impact on latency. Super fast.
Smart. But what about the long tail? The millions of rare queries, you can't pre-compute everything.
Right. For the really long tail, they currently fall back to their existing non-LLM models. Though they mention they have plans to eventually replace those fallback models with a distilled llama model.
A distilled model, what's that?
It's essentially a smaller, much more efficient version of a large language model, trained to mimic the performance of the bigger one on specific tasks. It's better suited for real-time use where latency and cost are big concerns, like serving those tail queries.
Okay, that makes sense. A hybrid approach. Cache the common stuff, use efficient models for the rare stuff. But managing all these different models, the QU classifiers, the rewrite models, the discovery generators, the fallback models, it sounds like managing all of these models is actually complex from a system perspective. Is that right?
Oh, absolutely. It creates complexity in terms of deployment, monitoring, potential inconsistencies between the models.
Inconsistencies. How so?
Well, they gave an example. Think about the query, which is actually a brand of kombucha.
Oh, okay.
Their brand tagger model, part of QU, correctly identified, as a brand, good start. But then later in the processing pipeline, their spell corrector model, a totally separate component kicked in and changed to hummus.
Oh no, kombucha to hummus.
Exactly, which led to really confusing search results for the user. They searched for a drink and got dip.
Yeah, that's not ideal.
So their future vision, partly driven by issues like this, is potentially consolidating all of these into an SLM or a large language model,
A single unified model.
potentially,
Mm.
or at least fewer, more integrated models. The idea is that a larger, more holistic model might handle the query understanding, maybe even rewrites and discovery generation more consistently, avoiding these kinds of pipeline conflicts.
That makes sense. A more unified brain, less chance of crossed wires.
Right. And another potential benefit they see with using LLMs more deeply in query understanding is the ability to pass in extra context to figure out the customer's mission.
Beyond just the keywords, like why they're searching.
Exactly. For instance, can the system detect if a user seems to be buying ingredients for a specific recipe based on their sequence of searches?
Okay. If they search chicken, then broccoli, then soy sauce,
Mhm.
maybe they're making stir fry.
Precisely. And if the system can infer that mission, it can then generate much more relevant content. Maybe suggest other stir-fry ingredients or even recipe links rather than just showing isolated product result.
That feels like the next level of helpfulness, understanding the goal.
It really does. Moving from keywords to intent and maybe even to the whole shopping mission.
So looking back at this whole journey, Instacart highlighted 3 key challenges they really had to nail to make this work. What were they?
Yeah, 3 big ones. First was aligning generation with business metrics like revenue. It wasn't enough for the LLM output to just look good. It had to demonstrably improve clicks, add to carts, and ultimately revenue. That required careful tuning and experimentation.
Right, it has to work for the business too. What was the second?
Second was improving the ranking of the content itself, especially the new discovery content. There are traditional ranking models like PCTR, predicted click-through rate,
Right.
or PCBR, predicted conversion rate, rely heavily on past user interaction data.
Which doesn't exist for brand new discovery suggestions.
Exactly. So those models struggled. They had to explore other strategies, like using diversity-based ranking to ensure a good mix of relevant items were shown, even without historical click data.
Okay, ranking the new stuff was hard. And the third challenge?
The third was evaluating the content itself. How do you make sure the LLM isn't hallucinating making things up? How do you ensure the suggestions meet Instacart's specific product needs and policies?
Quality control for the AI's output.
Precisely. And what's really fascinating here is that they actually used LLM as a judge for this evaluation process.
Using an AI to check another AI's homework.
Kinda, yeah. They leveraged LLMs to help automate the process of checking the quality, relevance, and safety of the generated content, which is a really interesting approach to scaling evaluation.
That is interesting. Okay, so to wrap up their experience, what were the main key takeaways they wanted to share?
They boiled it down to 3 core learnings. First, LLM's world knowledge was super important, especially for improving predictions on those difficult tail queries, where Instacart lacked its own data. The LLM filled those gaps.
Okay, general knowledge helped the long tail.
Second, while LLMs were super helpful, we really found success by combining the domain knowledge of Instacart with LLMs. That fusion was key. Neither worked as well in isolation.
The blend of general plus specific.
Got it. And third, evaluating the content as well as the query predictions was far more important and far more difficult than we anticipated. Evaluation wasn't an afterthought. It was a major hurdle. And again, they highlighted the value of using the LLM as a judge there.
Evaluation is hard, maybe harder than generation sometimes. Makes sense. And just briefly, they also mentioned experimenting with natural language queries, like typing full sentences into search. Ask Instacart.
Yeah, they touched on that. Things like asking healthy foods for a 3-year-old baby.
Yeah.
Their initial learnings there really echoed the main themes. First, you absolutely need to inject a lot of Instacart context, what products are available, nutritional info, etc., into the LLM.
Context again.
Context again. Second, handling the sheer variety and ambiguity of natural language requires a robust, automated evaluation pipeline. You need systems to check if the complex answers are accurate and safe.
Makes sense.
And third, you need to pass the understanding gleaned from the natural language query downstream. If someone asks about gifts for Mother's Day and the LLM identifies perfumes as relevant, that context needs to flow to the ranking system, so it prioritizes women's perfumes, not just any perfume.
The context has to persist through the whole system.
Exactly. Context is king.
You know, what's really fascinating here, reflecting on all this, is how deeply these AI models need to understand not just the words we type, but the specific context of our world, whether that world is grocery shopping on Instacart or, well, anything else we're searching for online.
It's not just about language processing anymore. It's about world modeling, or at least domain modeling.
Right. It's not just the dictionary definition, it's the intent behind the words in that specific situation.
And if we connect this to the bigger picture of AI development, it really suggests that maybe the most powerful, the most impactful applications of AI, especially in the near term, won't just come from purely general intelligence figuring everything out on its own. Instead, it seems like the big wins come from combining that broad, general knowledge that LMs have with highly specific real-world data about actual human behavior, about the nuances of a particular domain, like Instacart did.
So it's the fusion, the synergy between the general AI and the specific knowledge base.
It really looks that way. That specialized learned context seems to be what makes the difference between an AI that sounds smart and an AI that's actually useful in a specific task.
So thinking about this for you listening, what does this all mean the next time you type something into a search bar, whether it's for groceries or a product or just information? Maybe consider how much more powerful, how much more helpful these systems become when they learn not just the words in the dictionary, but the unique way you and millions of others actually interact with the world and the specific context of your search.
Yeah, it's about building intelligence that doesn't just understand language, but truly understands or at least effectively models your mission, your intent in that moment.
Fascinating stuff. A lot to think about in our everyday interactions with search.